The first stage of our video is to introduce background of topic. It is well known that the emission of carbon dioxide is a critical reason of global warming. How to reduce and dispose the emission of carbon dioxide has already been concerned by a lot of people. In this video, we choose an environmental technique company which is aimed to transfer carbon dioxide into a recycling chemical product as our study objective. In this case, we will use a mathematical model to simulate the relationship between the disposed quantity of carbon dioxide and the average cost of the treatment of carbon dioxide. Now we will talk about mathematical model. For this question, we use fx equals ax squared plus bx plus c to calculate the maximum value and minimum value for fx. We can use the derivative to solve it. The derivative of fx equals 2ax plus b. Suppose that the derivative of f equals 0. We can figure out that x equals minus b over 2a. Assuming a is more than 0. If we have a look at where the x is less than minus b over 2a, we can find that the derivative of f is less than 0. Reflected on fx on the intervals, fx is decreasing. When x is greater than minus b over 2a, derivative of f is more than 0. Which is this part. Reflected on fx on the intervals, fx is increasing. So it is easy to understand that the point where x equals minus b over 2a is the global minimum of the function. Similarly, assuming a is less than 0, the point where the s equals minus b over 2a is the global maximum of the function.
For our question example, here the equation will show the relationship between monthly average cost of the treatment of carbon dioxide and the monthly disposed quantity of carbon dioxide. And the question will be how many should the monthly disposed quantity to be to minimize the total disposed cost. Let's solve the equation. If y, the equation of y will be this, then the derivative of y will be x minus 200. And we should know if we want to get the local minimum, then we should let the derivative of y equal to 0, which means x should equal to 200. And then we can prove this by using this table. When x is smaller than 200, the derivative will be negative, and then the curve of y will decrease. And if the x will greater than 200, the derivative will be positive, and then the y will increase. We also can show this by a photo, by diagram. Let's see, this will be the derivative of y, the slope, and when it's 200 it will be 0, and there will be the curve of the y, the equation of y, and when it's around 200, then it will be 0, the slope. So it will at this, then this time the slope will be 0, which will equal to the point here.
Through the analysis we just finished, the minimum cost of disposal occurred when the quantity is 200 tons. We recommended that similar company should do the same type of analysis when they structure the company. In other words, structure the company's location and serve areas to make the project to be effective and efficient. We think that it can help the development of the similar departments as this company and make effort to the climate change.